Hi there. In wind turbines, there are a variety of heavy-duty bearings to cope with the immense loads. I will be explaining pitch bearings. Pitch bearings are used to connect the blades of the turbine to the turbine hub, which is the rotating nose of the turbine. There are three of these bearings, one for each blade. Each bearing will need to withstand high axial loads from the blade's weight and centrifugal force as it rotates. They will also need to cope with radial loads, which are highest when the blades are horizontal to the ground. But why is a bearing needed at all? Why not just bolt the blades rigidly to the hub? The gearbox and the generator are rated to accommodate a certain speed, up to 20 RPM. If the blades rotate faster, then the gearbox and generator could be damaged. To prevent the blades from spinning too fast, the angle of the blades to the incoming wind can be adjusted to reduce the force to an acceptable level. This angle is called the pitch of the blade. It is made possible by the pitch bearing shown in blue. Pitch bearings are double row ball bearings able to withstand the extreme radial and axial loads. The outer ring, shown in blue, is bolted to the inner wall of the hub. The blade is bolted to the inner ring, which is driven by a pinion gear connected to an electric motor. The electric motors adjust the pitch to optimize power generation and decrease the risk of damage to the gearbox and generator. The bearing itself is a double raceway ball bearing, which is made up of an inner ring. Separators space the balls, but in newer bearings, each separator is split into two segments. This is to avoid the separator failing when excessive loads distort the bearing. The balls are seated in the raceways. They're inserted through holes in the outer ring during assembly. The bearing is lubricated with grease due to the low speeds, and because grease is better for keeping out foreign matter, which is a problem since this bearing will be exposed to rain, sun, and dust. In addition, newer H-shaped seals are also UV-resistant polyurethane to cope with the sun. The raceways are machined with a Gothic arch to ensure 4 points of contact with each ball. Under excessive thrust loads, these contact paths can break away or the balls may fracture. This can be mitigated by making the arch profile tighter to the ball to allow for the load to be better distributed. I hope you found this video helpful. Thanks for watching.